Today is Janmashtami, and I would like to talk about a continuous ambient air quality monitoring stations data at Vasundhara, Ghaziabad, UP. Before that, I would like to give a preamble of what is the status of continuous ambient air quality monitoring stations in India. There are about 558 continuous ambient air quality monitoring stations, out of which 131 cities have been declared as non-attainment cities. There are about 804 manual national ambient monitoring stations in 334 cities in 28 states and 6 union territories. Manual monitorings are happening at a rate of 2 days per sample per week. 104 samples is collected in a year, and 5 years data is reconciled to find out whether a location is attained or non-attained. That's how 131 locations in the state, in the whole of the country, has been declared as non-attainment cities. So a little comparison. A continuous ambient air quality monitoring station samples at a rate of 15 minutes per data, 24 hours, 365 days. And the data strength is about 1,440 data per day, 43,200 data per month, 5,18,400 data per annum, with 95% data availability. And this amount of valuable information is not used properly in our country. So I want to educate the younger minds, the regulators, and the environmentalists at large to understand how to use this data for the betterment of the society. I would like to also give you an input on to say that what's the cost of establishing this continuous ambient air quality monitoring station? It costs around 1.25 crores for establishment, and with the operational maintenance cost of 3 to 5 lakhs per month. So, telling about all these things, so what is the point that I want to traverse is the question that everybody would like to have. So I would like to underline the problem statement as follows. Whether the pollution has happened in this location or not, and which are all the pollutants that are predominantly affecting the location and the society at large, and which direction it got affected and area affected. What is the root cause analysis? What is the diurnal plot and recurrence of pollution daily, every day, every month, and every year? What is the solution? What is the mitigation management plan? Whether monitoring is happening correctly or not, and the purpose of establishment of such a station is representative or not. Is there a representative data happening at that sampling location? Are we spending properly on the continuous ambient air quality monitoring stations appropriately for the cost it's been invested? Are my underlying questions. With these questions in my mind, I started this work randomly, picking up a station called Vasundhara at Ghaziabad. I have not been to that place, but I can understand the language which the data talks. And I was to traverse this language to the layman, to the environmentalist, to the regulators, to the students, and to the society at large at UP to understand what is the quality of air that they are breathing and health that is affected. Okay, who are you? Why you want to tell all these things to us? Okay, I am also a regulator. I was a regulator. I retired as a deputy director, Tamil Nadu Pollution Control Board, with 36 years of service from Tamil Nadu Pollution Control Board. Okay. I also established a center called Care Air Center in the year 2010, and which was the first online monitoring center established in the country, which has also been documented in the Planning Commission of India. Taking this as an insight, I would like to go into the presentation to give an insight to the people of Uttar Pradesh and also to the country and also to the whole world around to understand what is the quality of data analysis and what sort of information that we can derive to take appropriate actions. Here we go. The location is Vasundhara, Ghaziabad, UP. And the provider is UP Pollution Control Board, and each data is 30 minutes. And the data period that we are taking for studies from January to August 2023. This is the National Ambient Air Quality Standard that everybody knows, declared in November 2009. This is not I would like to talk about, but this is what I would like to emphasize upon. The 24 hourly or 8 hourly or 1 hourly monitored values as applicable shall be complied with 98% of the time. They may exceed the limits, but not on 2 consecutive days of monitoring. My observation is nearly all months is getting exceeded for most of the parameters declared under National Ambient Air Quality Monitoring, National Ambient Air Quality Standards. This is the PM10 24 hours rolling average standard of 100 per day. And you see all the months from Jan to August, nearly all the days it has exceeded. This I have created as a top 10 polluting months, in which I found that March, it is highly 31, followed by May, then January, then April. But if you see this side, the exceeding days, it is 31, 31, 30, 30, 30, 28, 27, 21. Nearly all days, it has been exceeding the standards of for PM10 for 100. And the predominant wind direction from where the pollution originated is from north of northeast and went and affected at south of southwest for all the month up to June. And thereafter, from east of northeast to west of southwest in July. This is some seasonal variation. But this is the directions from which the pollution came and the pollution got affected. This is the PM 2.5 exceedance for 24 hours rolling average of 60 microgram per meter cube. You see a green line here. This shows 60 microgram, and you can see the exceedance of all the parameters throughout the study period. And this is the exceeding number of days. Probably mostly in Jan, February, and March, the levels were very high compared to other months. This is the NO2 24 hours rolling average of 80 microgram per meter cube. And you see some of the months it has exceeded the standard of 80 microgram per meter cube. This is a time series plot of actual NO concentration. I've taken NO, nitrogen and its oxides. You see the values recorded were more than 400 microgram per meter cube. This is something to be noted upon. So there is a source which is emitting NO at higher level. That is what is my indication that I would like to infer. This is the CO 1 hour rolling average of 4 milligram per meter cube standard. You can see a line yellow here. This is the standard. I can see the number of days it has exceeded, showing that combustional sources where CO is emitted has exceeded the 1 hour average of 4 milligram per meter cube and affecting the society. And the 8 hour rolling average of 2 milligram per meter cube is also affected. You can see that very clear. What about ozone? You see, the ozone standard is about for 1 hour rolling average is 180 microgram per meter cube. Ozone is not generated from any industry or any source. It is formed. It is formed by presence of sunlight and volatiles in environment. It is formed. And this is the levels in which it is exhibited in this area called Ghaziabad. So this much of ozone to be formed daily means there is high volatiles that is being let out into the ambient air and not monitored. This is one sort of an inference that I can derive from the data availability here with respect to ozone. And it needs a specific set of analysis called total organic carbon analyzer monitoring, total volatile organic carbon or TVOC analyzers, TRS, total residual sulfur, organic sulfur analyzers are the reliable sources from which we can draw some informations which can serve to the public and society at large. These are all pollutants which are at low concentration can cause cancer. That is the understanding that you should take it to. What about the 8-hour rolling average of 100 microgram? It has also exceeded. So this is very clearly saying that all the parameters, whatever we see through as per the national ambient air quality standards, it is exceeding, and exceeding. SO2, yes, it has exceeded the 80 microgram per meter cube level standard for the study period. The windrows, as I've already mentioned, it is predominantly from northeast, east, and southwest. So this is the monthly windrows, what is happening, and this is the attribute and direction from which the pollution came. This is a pollution rose. So with respect to PM10, from which are all the direction it has come and it has been attributed. Each month has been shown here. This is a percentile rose. Percentile rose means 99 percentile of the time or maximum pollution happened, 75th percentile of the time and 50 percentile of the time from which direction the PM10 has been attributed has been shown here. This is benzene. Benzene annual standard is 5 microgram per meter cube. I have just taken a time series data of benzene emission monitored in this location, and you see it has crossed nearly all days the standards of 5 microgram per meter cube, which is highly carcinogenic in nature to be understood. Okay, so till now, we did a time series analysis. Let's do some in-depth analysis called diurnal analysis. Diurnal analysis by using 3 parameters, PM10, NO, and CO. I chose these parameters to understand what is happening daily, 24 hours every day for the period of 8 months. This is how the pollution behaves. You see a blue peak which represents the PM10 and it is a double peak. One here, another here. So there is a morning peak around 7 and 8, and there is an evening peak at 21 hours. So this shows this PM to be contributed into the environment. There is a higher attribute of CO. And also there is an attribute of NO also. So what is the cause? It might be a combustional source which is releasing CO and NO is the cause for PM10 to be prevailing in the environment. And which is it? It is purely vehicular in nature. Is the all vehicles, combustion engines emit NO and CO. So the PM10 levels existing in the environment is because of purely vehicular pollution. I have taken SO2 also for a diurnal analysis with respect to PM10 and compared with CO also. You see, the green one is the SO2. It showed somewhat a relationship, but not a major relationship as CO with PM10. Then I did a correlation heat map study to understand what is the correlation between PM10 and CO. The correlation heat map shows the relationship between PM and CO is 0.88, which shows it is really has an affinity. That is, whenever CO is formed, PM10 was also released. With respect to PM10 and SO2, it is 0.55. Moderately, it is having some correlation. CO and SO2, 0.57. Again, moderately, it is having some um, affinity in formation with respect to PM10 and PM2.5. So it's a short story that I would like to travel and say you with the available data in this station that this station needs some action from the regulators, from the public, from the NGO, from the environmental group, largely to look into this matter really serious and safeguard the public health and also the people in UP. Thank you.